Welcome to the session about model-based design, parameter estimation, and process optimization in Industry 4.0. According to the schedule, we are expecting overall 6 presentations. If all presenters will show up, we have to take care about time pretty much. So please plan your talk about 12 to 13 minutes in order to have some room left for at least one question. So is the presenter of the paper Efficiency Improvement in Polycrystalline Solar Panel Using Thermal Control Water Spraying Cooling in our room? It should be Dominic Ramere.
So very thankful to the organizers, the organizing committee of this conference. Thank you very much for the effort, for taking
Dominic, now at the moment we cannot see the presentation.
You cannot see it, or cannot. Let me try and let me do it again. I think it will be visible. Or you see it now?
Yeah. See it. And please to try to keep time discipline in 12-13 minutes or so.
Oh, okay. No, thank you very much. Yes, the authors of this paper is Timothy Lasende and Dominic Ramere, both from University of Johannesburg, South Africa. The topic of our conference is efficiency improvement in polycrystalline solar panel using thermal control water spraying cooling. The reason for this topic, the increasing demand of electricity generated from main grid is very high, so that it is overloading the grid. So now we have noticed that the harnessment of solar system is one of the most considered in the market currently. So the background of now we'll go to the background. Increase in the electricity demand. That's the reason why what we're looking for. That's why we have noticed that there's high harnessment of solar panel, the solar system in many industries, especially for the 4th industrial revolution, as electricity generation and availability is regarded as the main source of industrialization in the 4th industrial revolution. The rise in global price of fossil fuel is continuously increasing the prevalence of green energy generation, thereby contributing to solar energy demand. Due to environmental sustainability drive, government and industries are burdened with the responsibility of protecting the environment through dependence on alternative energy source. So if you look at solar, and we've looked at the advantage that solar energy is free, and the challenge, the other problem that associated with solar energy is the absorption. When it's very hot, the solar glass, the glass of the panel becomes very hot, so it also impacted the electricity generation of solar panel. As we have seen that the solar panel can operate effectively at the temperature ranging between 15 and 35 degrees Celsius. So in this research, we have proposed a low-cost microcontroller-based water spraying solar system using temperature detection using Arduino board. On the design, this design, it has got a control circuit. On the control circuit, we've got the microcontroller and the comparator. The comparator is the one that is comparing the temperature, the range between the temperature between 15 and the given one and 35 degrees Celsius. Once the temperature start to exceed 35 degrees, when it goes to 36 and above, then it triggers to the microcontroller that the microcontroller must activate the spraying system of the water spraying system that will energize the pumping circuit. From there, the pumps water. After that, the water it will go to solar temperature. When the temperature if the temperature is between 15 and 35, then the water stops spraying. Once the temperature is still above the temperature, then the RTD, resistant temperature detector, that the temperatures are above, it takes it to comparator again, it goes to microcontroller. The microcontroller is the one that is making decision based on if the system temperature is within the range or is above. When it's above the range, it sprays the water again so that it can maintain the temperature of the solar panel to range between 15 degrees Celsius and 35. This is the operating table for spraying. We've got, because the comparator, it has got inverting and non-inverting amplifiers. If both they read 0, there's no spraying. 0 means the temperature is okay. The temperature is between 15 and 35. One is 1, it means the temperature is above. And when it's 0, it starts spraying. When the temperature get above, oh, no, sorry, I did a mistake. It's a vice versa. 0 is below, 1 is above. This is the truth table of how it is spraying. This is show the problem that we have identified with the energy generation by the solar panel during from 6 o'clock in the morning up until 12 o'clock. Before the sun gets hot, it generates good electricity. But when the sun starts getting more hotter, there is a challenge with energy generation. So this was part of an experiment that was performed. It is the data that was collected from the experiment during the hours. With the first one, we started 5 o'clock in the morning up until 9 o'clock afternoon. So all these voltages are the averages that were combined in a period of 5 days. So for around between 5 o'clock and 6 o'clock, if you check the power input, like here is 6.2, and the current is this. These are the averages. It's average of what is generated by the solar panel. The results. This was the data found before we implemented this strategy of a spraying system, of solar spraying system. And the other one, the results we got after. It's the results we got after implementing the strategy of spraying the solar panel with water for cooling. So this is the comparison of the two power generated by both solar panel, the one that is equipped with a spraying system and the one that is without a spraying system. And here is the comparison was further taken into the comparison was made into the graphs. If you look at the graph for power, for the graph of power generated by solar that is equipped with the water emission system for spraying system, it is bigger from, if you check from approximately 10 o'clock in the morning, because it starts to get more hot. The more it becomes hot, then there's a drop. There's a drop in terms of energy generation. So if you use that one for spraying, the drop in energy generation is slightly compared to the one without the spraying system. So from there, these are the results that we got based on the experiment, where we compared energy generated by both solars. Then we found that the energy generated by solar with a spraying system, it generated 6.264, and the one without a water spraying system is 5.37. Then that's when we get the efficiency of 16.65. This is the percent, the improvement that we picked up in the experiment. So in concluding, the results of water spray solar algorithm, there is considerable improvement in the power generation by solar panel, with a significant increase in energy efficiency by 16.65%. So it is very important to harness this method, because we have proved that it is working and is efficient. Thank you very much. I'm done with my presentation.
Thank you very much, Dominic. So, is there a question from the auditory to the presenter? So I do have one myself. When you have been comparing the variant with or without the water spraying cooling, did you have an experimental setup with both variants that you could really compare at the same time, at the same day, with the same weather conditions and so on? Or was it done on different days?
No, I put two solar panels together for the experiment. So I was taking when I collect data, I collect it at the same time. I visit the one with without the spraying system and the one with the spraying system. They were very close. I just
so it was really done in a synchronous way, so to say.
Yes.
Okay.
Yes.
Yeah, thank you very much again, Dominic Ramere, and we continue with the third talk. The presenter is Ghulam Muhammad Ali. Good morning.
Good morning.
And the title of the presentation is Simulation of Ground Bearing Pressure Profile under Hydraulic Crane Outrigger METS for the verification of 16-point combined loading.
Okay.
Please, Ghulam, go ahead.
So can you guys see my presentation here?
Yeah, that's fine.
Okay, that's good. Okay, first of all, my name is Ghulam Muhammad Ali, and I'll be presenting my paper, which is about the simulation of ground bearing pressure profile under a hydraulic crane outrigger METS, and regarding 16-point combined loading and further verification using FEA. So let's come to the scope, introduction, and the traditional way how we calculate ground bearing pressure, development of new equations, case examples, FEA verification, which is the major part, results, future aspects of this of the research. Okay, first come first, motivation. So from 2000 to 2009, there were about 50 deaths in crane industry because of the ground condition. It means that the poor ground condition. And how to rectify it? We use mats, we use compacted ground, and to use mats, the first thing is to calculate the ground bearing pressure exerted by the crane itself. For that, we use crane, first of all, the weight of the crane, the payload, and then that weight is divided on the crane mat, which exerts pressure on the ground. And as a result, the ground exerts a resistance, or you can say the a reaction against that pressure to make it stable. So how we calculate this ground bearing pressure, how we used to calculate was that we use these three factors to calculate the forces, and this is and these are the equations which we use to calculate the forces under each outrigger. Later, these forces are basically distributed along the area of the mat to get the pressure, considering it uniformly distributed. So the process is that we calculate the forces and then we divide it by the area, and then divided by the area, and then we get the pressure. But in our new methodology, we presented here that we can calculate ground bearing pressure directly under the crane mat. Instead of going into two steps, we can go into one step. And this method also came up with the results that the pressure under the mat is non-uniform in nature. It means that some parts of the mat will be exerting more pressure as compared to the other part, as compared to the other corner. So we got 16. So we got 16 ground bearing pressure values instead of 4. Before it was 4 because there were four mats, but now it is 16 because 4 mats and 4 corners for each mat. For the case examples, we took a crane, GMK 7550, and we calculated the manual calculations. We took the values from the traditional way, and further we built a model in FEA using ANSYS to verify that how much we are accurate in getting the results from our new method. For FEA, it's very simple. You just build a geometry, then generate mesh, apply boundary conditions, obtain solutions, and display results. Here you can see on my, on your left, that on each sleeve angle, the ground bearing pressure under the crane mat is changing. Even for a single mat, it's not uniform. It's different on different edges. It's different on different corners. Now comes the part that about the results and about the simulation, that how it worked. These are the results which showed that the traditional the line in the center, which is the bold one, is the traditional ground bearing pressure values, which is the old one, which is the previously used method to calculate the values. And you can see that FEA values and the manual values, a few of the corners of the mat are exerting more pressure, which creates a serious concern about the method which are used in the industry to calculate the ground bearing pressure. If it is exacting more, so it means that more strength mat or more area is required under the mat to cover it up. And this also shows that the pressure under the mat is not uniform. It's different at different corners. Let's talk about FEA versus the manual, the new method. And we came to know that the results were very close, near about 1 to 2%. 1 to 2% percent variation between the FEA values and the values which we got from our new method, and it shows that that our new method is working very accurately and is giving the exact ground bearing pressure under the mat instead of just dividing the forces with area. So this was our result, and future work will be a little bit hectic because we have to develop an application which can calculate ground bearing pressure calculations using the proposed methodology. I mean the method we have just proposed. We should have an application so that the riggers or the engineers on site, they can just calculate it using that application instead of going through each manually. And further we have to work on zero ground bearing pressure scenarios where the crane goes for the tipping. When the crane goes for the tipping, it means that the pressure at the back of the crane is almost zero. That's why everything is on the front side, close to the load. So that that has to be calculated and that has to be developed. The third future aspect will be to think about the crawler cranes, because the crawler cranes, we also consider that the pressure along the width of the track is uniform, but these results from this research creates a serious concern about the calculations under the crawler crane. So we have to think about that one, and we have to calculate and we have to develop something new for that one. Thank you. Anything, any question?
Thank you for your talk. Are there any questions? So then let me start with a question. We've catched up a little time, so we have time for 2 questions in case.
Sure.
The simulation in which you have been applying is runtime an issue in this simulation? So what about runtime requirements?
The runtime requirements means I cannot understand it right now.
Means how long does the a simulation run take?
Well, no, it wasn't about the timing. It was about the values. More concerned about the values, that whether they are, whether they are accurate, accurate with the manual or not. So maximum it took 1 to 2 minutes for the simulation to get all the time. To get all the values. So the main concern was the values itself, not about the runtime, because our approach was to compare both values and to check that whether our new method is accurate or not.
Okay. The reason why I was asking was that we, in a project 2 or 3 years ago, we did for crane design, box type boom design, simulation-based optimization. And if we have to evaluate millions of simulation runs, runtime becomes an issue, even if it's just minutes for a simulation run. So that's why I was interested in the runtime characteristics of the simulation here.
So let me to share it for the model. We just showed gave the forces and the location of the forces on the model. Mm-hmm. So if we go for every part of the crane, that will be so extensive and that will really take so much time. So our concern was the final forces on the mat. That's why we just took major parts as one unit instead of giving it a small parts separately. So it took us less time because we just combined them. Combined the parts into one major part, upper structure and the lower structure. So basically, there were basically 2 parts, major parts, and from those parts, we just calculated the forces exerting on the mat. So if you go about the stability of the crane, that is really will take much more time, because then you have to check the bending of the beam and the bending of the boom, load, dynamic loading, everything. That will be so extensive. To save the time, because our main concern was that how much we are accurate in developing a new method.
Okay, yeah, I see. So thanks again for my question. Is there another question? Seems not to be the case then. So thanks again, Ghulam. And we can continue with the fourth talk. I've seen already Orlando Corigliano.
I'm here, present.
Okay, that's great. And the title of this presentation is Preliminary Design of AR SOFC Cogeneration Energy System using Livestock Waste. Please, Orlando, the stage is yours.
Thank you. Can you see my presentation?
Yeah, it's working.
Okay, I will start. So this presentation concerns on the preliminary design of an anaerobic reactor solid oxide fuel cell cogeneration energy system using livestock waste. The authors are Engineer Corigliano, De Lorenzo, Professor Fra Giacomo, while I am Orlando Corigliano and I am the speaker of this presentation. The context in which this work is developed is that of the green and clean technologies from waste to energy chain, whereby the systems are called to be high efficient, environmental sustainable, and devoted to recovery and reuse of waste. Clearly, the circular economy and the Industry 4.0 with its parallelism with Agriculture 5.0 will fit the above-mentioned characteristics, where smart systems and more efficient processes has to be the primary rings of the chain. Well, this presentation reports on a sizing procedure for an integrated anaerobic reactor and a solid oxide fuel cell energy unit. Energy plants of this type are strongly encouraged nowadays. Without going into detail, this slide shows many reasons why the biomass waste valorization for energy purposes is strongly encouraged and incentivized in view of Industry 4.0 roadmap. This work has therefore the aim of highlighting the benefits and of indicating the modalities to follow this new industrial revolution. Here we have the path of the work that we have developed. So I'm going to present the plant layout. I'm going to present the theory and calculation that which is behind, and then the calculation algorithm to achieve the dimensioning of the subsystems and therefore their performance. An application to a case study is made to test it. Finally, some considerations for the results achieved to connect to the Industry 4.0 vision. So we have in this slide the plant layout. As we can see, biomass is properly collected and organized in the substrate before being loaded into the anaerobic plant. The latter gives rise to biogas as well as digestate and waste. After cleaning up, the biogas enters the fuel cell energy unit, where it is firstly processed in the indirect internal reforming with water steam and with the recirculated anode of gas. The gas, which is rich in hydrogen, is subsequently converted into electric and thermal powers. So the exhaust of the fuel cell unit is totally oxidized in a post-combustor in order to breathe the fresh fluids. The theory and calculation starts from assessing the mass and energy balance of the system in order to have the comprehension of the variable involved and so optimizing them. As for the reactor, the minor substrate is treated with water to be pumped into the digester. The output is biogas, digested and separated from water. The same biogas is then fed to the fuel cell with water and air to have exhaust gas, which is mainly steam with carbon dioxide. As for the energy balance, it is necessary to well define the boundary in order to assess all the energy terms concurring to the process. This aims at quantifying the useful energy net of consumptions associated to the different phases, like the transportation for fresh biomass, pre and post treatments, the digestions, and the disposal of the process residues. We have in this first slide the anaerobic reaction modeling. The numerical modeling is set on a resolutive approach according to Boswell model. Boswell model is this reaction that accounts on a molecule composed of carbon, hydrogen, oxygen, nitrogen, and sulfur that is treated with water to have methane, carbon dioxide, ammonia, and hydrogen sulfide. For this reaction, it's necessary biochemical characterization. First of all, to have the mass composition of the waste, and then to have some biological parameters as the total volatile solids. What about the numerical modeling of the SOFC energy units? It aims to assess electric and thermal powers as function of some operative parameters as the methane content, the mass flow rate available, the recirculation fraction of the anode exhaust gas, and the fuel utilization factor. Therefore, electric and thermal efficiencies have to be assessed to have the comprehension of the system performance. The calculation is based on an iterative cycle. Without going into detail, when the convergence is attained, the performance of the first unit, that is the anaerobic digestion, is attained. Therefore, we have the biogas flow rate and its quality in terms of methane percentage. The same biogas becomes an input data for the SOFC energy unit algorithm. Analogously, the calculation procedure for the SOFC starts with the definition of the main input parameters as anode exhaust gas, the recirculation factor, and the fuel utilization factor. After a more complex cycle convergence, resolution is attained and the SOFC unit is dimensioned. The case study refers to a mid-sized livestock farming with 250 cattle and a surface of about 17,000 square meters. About 23,000 kilograms of manure are available daily. So without going into detail, this slide we show the organic substrate organization. The substrate is based on exploiting the available waste, that is manure and corn. Obviously, other substances are taken from outside to enhance the mash to be fed to the reactor. The table reports the biochemical characterization as aforementioned. Well, then the results are carried out. Against 32,000 kilograms of substrate, almost 1,800 cubic meters of biogas are produced with a methane content of 54%. The anaerobic reactor, to this purpose, needs a volume of 1,300 cubic meters, a diameter of 15 meters. This slide, instead, illustrates the SOFC energy unit mapping as a function of the recirculation factor and of the fuel utilization factor. The working point is chosen in order to maximizing the electric production. So we have to set a choice on a specific criterion. In this case, the criterion is that of maximizing the electric production. So we choose the solution 2. In this solution 2, we have we have the plant that shows an electric efficiency of 33% and a thermal efficiency of 47.5%. Here we have the plant energy balance, just to treat some variable without going into detail. The fuel cell system is operated at 700 Celsius degrees and 1 bar. Based on the aforementioned criterion, the plant energy balance is assessed against the total internal electric self-consumptions of 55 kilowatt and the thermal power of the 76 kilowatt. We have a net production of 100 kilowatt for electric power and about 100 kilowatt for thermal power. Therefore, this allows the user to face the energy needs to satisfy company objectives. In fact, in this slide, we can see that in winter time, the electric needs is almost fully satisfied. While in the summer, it's half satisfied until 2 half days. Otherwise, for the half days, the electric need of the user needs an integration. Otherwise, the thermal supply is not sufficient to cover the thermal needs of the user. Anyway, this implies a very strong and a very important economy saving for the user, because in the opposite case, the user would have bought this energy from outside. Well, in this slide we have the conclusion and some consideration for Industry 4.0 and circular economy vision. The main circular economy targets of sharing, lending, reusing, and recycling products can perfectly be matched in this field. In fact, the plant of these systems well fit this kind of context. For example, even small livestock farm can join in consortia to share their products or to share their resources. Therefore, integrated systems, IRs, SOFC, are perfectly in favor of this. With respect to this, Agriculture 4.0, which inherits all the guidelines from Industry 4.0, could massively increase in the next decades, given the expectation. Therefore, I think I finished, and I thank you for your attention.
Thank you very much for your presentation.
Thank you.
Are there any questions? In case, please just raise a hand. I don't see, so I will take the freedom to state a question which I'm really interested in. I suppose that the energy density of livestock waste is not too high. So the question arises also about transport logistics to the reactor station to somehow avoid that the energy for transport is in the same relation than the energy gained then back from the reactors. Have you been considering those transport logistics aspects also?
Yes, in fact, yes, you're right, and I thank you for this observation that I agree. Yes, the energy density is not so high. In fact, in the specific field we have 50, 60. The efficiency of the anaerobic reactor is 50, 60 cubic meters of biogas for 1,000 kilogram of biomass waste treated. But you have to think that the biomass is a waste, so he's a burden for the user, for the owner. So the user has to sustain a cost to dispose this biomass waste. Well, actually, we have considered we have to consider the fuel that it is associated to the consumption for the transportation of biomass or its waste, because the logistics cannot be considered a priori, because we are going to build this kind of plant where the resources are, just for this kind of situation.
Okay, I see. Thanks, Orlando, for answering this.
Thank you.
So I don't see a raised hand, so let's please continue with the next presentation. Next presentation is intended to be given by Mikhail Belkin or Dmitriy Fofanov about microwave photonics approach as a novel smart fabrication techniques of a radio communication jammers. Is someone here to present this paper? Yeah, Dmitriy is here. We can already see the presentation slide. So please go ahead.
Okay, just a minute. Can you see my presentation?
Yeah, now we can see it again.
Okay. So the title of our presentation is Microwave Photonics Approach as a Novel Smart Fabrication Technique of Radio Communication Jammers. And my co-authors are Mikhail Belkin and Alexander Sigov. We are all from Ramere, Russian Technological University, Moscow. Well, a novel technique to fabricate a responsive radio communication jammer, the purpose of which is to suppress a radio signal with a detonation code. is to effect of denial of service. It is proposed and highlighted. The distinctive feature of our approach is the processing of received radio signals when, instead of the operation of introducing noise interference into each radio channel, exclusively used in existing multi-channel jammers, a common single-channel device with optoelectronic processor is exploited. The result of our investigations of response time performance of the proposed jammer using a co-simulation approach with a specialized VPI Photonics design suite modeling tool and versatile MATLAB software are presented. So at present, the problem of effectively countering terrorist attacks using radio-controlled improvised explosive devices is almost worldwide acute. Various terrorist groups and individual terrorists exploit a common code transmitted over a radio communication channel. And here are some of the bands that they use. For example, walkie-talkie or smartphones. In addition, due to the rapid development of fifth-generation mobile telecommunication networks, an expansion in the range of the operation up to 6 GHz can be expected, which must be taken into account when developing new generation countermeasures. In a number of industrially developed countries, production of radio communication jammers has been already established. For example, Crew Duke or Crew Vehicle jammer and others. Currently, some research universities are actively involved in this development. And following this tendency, we recently proposed and investigated a microwave photonics concept to design a jammer, validating through simulation and proof of concept experiments its feasibility and prospects from the point of view of a significant simplification of the circuitry and improvement of size, weight, power, and cost characteristics. The generalized block diagram of a modern jammer is demonstrated in this slide. It consists of a receiving unit with an antenna, a transmitting unit with a power amplifier and transmitting antenna, a supply control monitoring unit, and a central unit which is essentially a digital electronic processor. This type of jammers are built on the basis of the traditional purely electronic approach. And their shortcomings are the need to frequency scan the results of receiving in a number of narrowband receivers, up to 30, which leads to a relatively low reaction rate, from 10 microseconds to units of milliseconds. The need to store and select a masking noise interference from the library of optimal interference signals, which also reduces the reaction rate. And after all, the complexity of the circuitry, which leads to a deterioration of overall dimensions and increase in the cost of the product. So we propose a new microwave photonics-based design, which instead of operation by introducing noise interference into each RF channel, use a common single-channel optoelectronic processor, which consists of an electrical to optical converter, optical retardant circuit, which is essentially a coupler, and optical fiber to delay the signals, followed by optoelectronic converters, and finally a low-noise amplifier. So we performed some simulations, and we used a VPI Photonics design suite in combination with MATLAB software, and there is our layout. Some parameters are demonstrated in the table. After the simulation, we performed experimental research for the prototype. As you can see, we used a directly modulated laser, optical splitter, optical fiber to delay signal, a photodiode as a detector, low noise amplifier, signal generator, and digital oscilloscope. This is our simulation results. We investigated error vector magnitude and figure of merit versus a number of recirculations in this optical scheme. Left figure is for 10 megabit per second and right figure is for 100 kilobit per second. The horizontal dotted line in the graphs shows the standard degradation limit of the transmitted signal with QPSK that equal to 17.5%. And here are the results of prototyping. In this figure, the input waveform lower is painted by green. On the other side, the output waveform is painted by red. Figure B demonstrates an effect of sharp deterioration of output signal quality, upper oscillogram, in comparison with input signal, thanks to counteraction of the proposed microwave photonic jammer. The following outputs can be drawn from our modeling and experimental study. In the investigated jammer, the condition of an unacceptably large degradation of the output signal is satisfied at any bit rate, and the level of degradation increases as the number of recirculations in the optical recirculation circuit increases. Minimal time delay of the proposed jammer when recirculation loop is open can be estimated as small as 14 nanoseconds. That is, the total response time is near 164 nanoseconds, which is a result comparable to the world's leaders. And even a single recirculation is sufficient to ensure reliable degradation of the jammer's output signal, which confirms on the simulation results. Well, in this walk, to continue the study in detail of a novel technique to fabricate a responsive radio communication jammer, we examine the response time of the proposed microwave photonics radio communication jammer, which is one of the most critical parameters of it. An important advantage of our approach is the significant simplification of jammer circuitry, which should lead to a radical improvement in size, weight, power, and cost characteristics. The results of our investigations of response time performance for the proposed jammer using a computer-aided design and cost simulation in specialized optoelectronic computer tool and versatile MATLAB software, and also experimental confirmation showed a multiple reduction compared to existing purely electronic devices in terms of size, weight, power. Our further work will focus on the study of the optimal principles of circuit design and the selection of radio frequency of the electronic and optical components of the proposed device. Thank you very much. Thank you for your attention.
So thank you very much as well for your presentation. Is there a question from the audience? Not yet, then I do indeed have one. You mentioned that you aim to optimize price and quality, which sounds like some kind of compromise finding. Do you plan to do this in a systematic way with multi-objective optimization, or rather with trying different simulation parameters?
Yes, we are going to optimize concurrently price of the components, price of fabrication, total cost of ownership for our clients, as well as maintenance costs.
Okay, but do you already have a plan for the technical setup? Will it be evaluated with a sophisticated simulation model and then optimized with some multi-objective optimization strategy?
Unfortunately, we don't have such a plan yet, and we should think about it, I suppose.
Okay, I see. So if there is another question to this talk, please raise a hand. I don't see a raised hand. So thank you again, Dmitriy, for your presentation and for sharing your findings. And now we have, apart from the official program, because this talk was originally scheduled to take place yesterday, but now we have it in this session, given by Honorato Pacco. And the title of his presentation is Simulation and Temperature Control in Convection DEHYDRATOR for Laboratory. Please go ahead.
Thank you very much. Good morning in America. Good afternoon in Europe. Look my presentation.
Yeah, we can see it.
Thank you.
But not yet in presentation mode. So yeah, now we have the presentation mode.
Thank you very much. My work is simulation and temperature control and convection data for laboratory. My name is Honorato. I work in National University of Moquegua in Peru. Thank you for accepting my work for presentation in ISM2020 years. Therefore, Industrial Revolution is a new age that take a quantity and quality into organization and management of chain of value. We have reached and increase the automation, convectivity, and globalization. Products, process, and business models have entered into the industrial world and growth within a new work, big data and analytic technological advances that allow the operation optimization of manufacturing process, as well as their supervision and integration with other process and systems used in plants. In this iteration system, the influence of model transfer and heat transmission. The most efficient iteration system will be system capability on keeping the maximum values of steam pressure and temperature gradients between the air and the inside of the products to their stage. This condition alone con high convection coefficient in the product surface can be maintained in several different designs. The Industrial Engineer Professional School of the National University of Moquegua doesn't just have a fruit of vegetal dehydration that could be used for practices in the various programs of disciplines. Therefore, this research is aimed to perform the temperature simulation and control in a large-scale convection dehydration by using National Instrument LabVIEW software to somehow teach the students how to design and develop for automatic forces convection dehydration. Materials, the visual materials will be used in this research. No? So the laptop computers, Win 4G of RAM and 500 GB of disk space. No? LabVIEW software, National Instrument Graphic Programming Language. LabVIEW's main fields of application are measurement and automation. Programming is made for using that flow model, which make these programs suitable for supervision, acquisition, and processing. No? They consist of front panel contain the interface and block diagram that contain the program's graph code. In this research, National Instrument LabVIEW software version 2016 was used to design the data acquisition system of the temperature simulation and control system for the dehydration system from the computer. Draw the interface created per 28 and the year 2015. Currently, biomass drying as a pre-combustion process has become a decisive factor to improve the efficiency on such process, both in the industrial and resident sectors. The temperature simulation and control system for large-scale dehydration of fruits and vegetables consist in an on-off temperature control in which the set point and the temperature decide when each is a maximum and minimum temperature. The maximum temperature is 2 Celsius above the set points, while the minimum temperature is 2 Celsius below the set points. If the set points change, the minimum and maximum temperature are automatically changed. The dehydration system comprises two tray chamber where fruits and vegetables are placed after being prepared in terms of size, shape, and weight. A PT100 temperature sensor is installed and the entry which sends signals to the transducer and show the chamber to or temperature when the temperature reaches the programmed value maximum temperature. The control system turns the header off when the temperature is below the programming below, the heating system is turned on. This operation is displayed graphically and in Excel. The dehydratation temperatures tested in the simulation and control system were 14, 16, and 17 cells. Instruction to create a virtual instrument. In the Project Explorer window, left-click My Computer and the new. In the pop-up window, select Instrumental Virtual. After clicking on Instrumental Virtual 2 window open on the right bracket and the other with a gray ground growth. These windows represented the block diagram and the front panel. This frontal panel and block diagram. To select by loop in the block diagram, right-click and add a new window called Functions. Opens show in Figure 2 by selecting this window express option. A menu is below the projects. Select the exit control option and the while loop options as shown in Figure 3. Block diagram of functions. Sure, national instrument. Figure 3. Process. While loops operation. The while loop shows that everything that is inside the rectangular ball be subject to the cycle and executed simultaneously. To select the delay options, open the functions window, then delete the menu in programming and select the timing option. A tool called while until X minutes multiple can be seen. This before allowing delaying the while loop execution in the number milliseconds provided by the user. The PT100 temperature sensor is a specific type of resistance temperature detector. Is a resistive temperature detector that is a temperature sensor whose measuring principle is given by the measuring of resistance, variation of a conductor as functions of its temperature. Figure 4. When a working range negative 100 to 400 Celsius. Next, our loop cycle is created a launch with a control to stop the system by means of the stop button. Next, a scaling converter is made for sensor data. When the temperature reading multiplication 100 times the sector value in order to obtain in the temperature reading indicator. By means of direct connection, supply is created for the thermometer. And on button is added to control panel to start G system. Then the case structures and created and the temperature indicator is placed inside. For the maximum and minimum temperatures comparison schematic programming, comparison and graded. If the temperature is above the G set points, G heater is turned off. Conversely, in the temperature is below on the set points, the header or header generation system is turned on. For sure process survey is created for the temperature reading and two indicators for maximum and minimum values. Criteria are written based on the condition or to turn the header on off. If the temperature reading is above the maximum, the header generator goes off. If the temperature reading is below minimum, the generator goes on. To understand the mathematical model that describes the process dynamic, it is important to know the model of operation is the rotation chambers. First, we must select the type of material to be dehydrated. The rotation temperature will vary depending on the product, and the type of products to dehydrated has been selected and introduced into the dehydratation chamber. The process can start. The physical phenomena involved in the hot air-driven dehydratation process, the decrease with the dehydratation chamber happens due to the temperature of the products when the dehydrator. In this case, to the base of the fruits or vegetable that enters the chamber of ambient temperature. Temperature increases with the dehydratation chamber. This happens when the heater is turned on and generates a flow of hot air within the chambers. Temperature decreases in the dehydratation chamber. This happens when the chamber's door is opened to remove the products or to place new products. Temperature increases within the dehydratation chambers. This happens when the product's temperature earns again recharge the programming temperature after closing the door. This is chamber situation. Air entrance, fan, head generator, dehydrator chamber, PT100, try one products. Results and discussions. As a result of developed programming of the temperature simulation and control system for large-scale fruit and vegetable dehydratation chamber, as can be seen in Figure 6 below, which shows the on for system activation button, the stop button, and the thermometer that records the data sent by the sensor collects inside the chamber. The figure and show clearly the location of the PT100 temperature sensor, the set points that needs to program it, the maximum and minimum temperatures programmed for the dehydratation chamber. The graph record in real time and the writes that allows recording that from the dehydratation process in Excel. Results. PT 100 temperature set points, temperature graph, breed per fruit national by Excel, while loop. It is a result. Temperatura máxima, temperatura mínima, temperatura normal. The front panel of the temperature simulation and control side, the LIVESTOCK fruit and vegetable dehydratation chamber is shown in figure 7 that illustrates in the system operation. The header is off in figure 8. The header is green light and on which means that the system is operating less than 17 cells in this case, the set point is programmed at 17 cells. Therefore, the maximum temperature is 17 to 17, and the minimum temperature is 518 Celsius. The PT 100 temperature sensor sends a signal of 0.5879 millions, and there the temperature reading show 518.79 Celsius. The system operation is time as shown graphically, and the sum time the operation that data are recorded. And results. Button stop on header graphic, temperature thermometer PT 100, temperature set points, max temperature maximum, temperature minimum. En results, front panel, the temperature simulation and control system for a fruit and vegetable dehydratation chambers with the header on green lights. If the temperature reading is the value of 16 Celsius, the header is turned on until the temperature increase back and keep constant. It has been shown that this system programmed in LabVIEW language works the same by as it was programmed by ISLAMS 2014. The graph code, the data control and acquisition system developed for the development of software and LabVIEW language for sizing of a waterproofing photovoltaic system. Conclusion: the system developed in LabVIEW language allows the visualization of all the parameters of interest during the execution of the on and off trials of the operation of the fruit and vegetable dehydratation system header. Block programming is possible using the LabVIEW language. It also allows the design of the front panel of the temperature simulation and control system for a fruit and vegetable dehydration chamber mean the purpose expected. The application of the LabVIEW programming software and PCs for temperature control is a fruit and vegetable dehydration chamber is very important as it allows the products to be preserved for longer times and transported through long distance con much lower base and volumes. Reference acknowledgements when change the information laboratory of the agroindustrial engineer and professional schools of the National University of Moquegua, Peru, and the people who made and present research. Thank you very much.
Okay, thank you for your talk. Even though we have already been running out of time a little bit, if there's a question, please feel free to ask. So doesn't seem to be the case. Then thanks to all attendees for being with us in this last session of today.